So the next topic is pretty interesting, and it takes me back to my childhood days. I remember going to theater to watch this movie called The Love Bug. It was about a car that could go on its own, had a mind of its own, did things on its own. And for us kids, it was fascinating to see a car that could go without a driver, right? And of course, it did all kinds of funny things which made us laugh. And then came Transformers, which showed extra level of precision there in the way it did things. It could transform into different things and be a car, and then came Tesla, which also showed that the car could go on its own without the driver, in which a lot of Americans proved sometimes very disastrously also that car could go on its own, right? One of the stories I remember back from like about 2 decades back is when cruise control came into cars. Somebody thought it was an autopilot, so they put it on cruise control and went back and had a drink. Of course, they woke up in hospital later. But fortunately, now we are at a different level where the cars are actually intelligent. And our next speaker, who brings with him 25 years of experience in IT, he is a passionate technologist and loves to apply technology to experiment on improving user experiences. May I please call upon the CIO of KPIT, Samir Kulkarni, on the stage, please. Samir, I hope you're making a magic car there, yaar. I really hope. I let the people to believe that now.
I'll use this. Thanks. Very good afternoon, everyone. And actually, he stole some of the opening remarks from me, actually. And exactly this is what we are. I mean, we have seen the cars that go on its own, and at the same time, we have not really, when we go out and sit in our car, we really don't see those things happening. And that's predominantly the automotive industry is all about. It takes years to actually bring any feature back in a car, but not anymore. I mean, that's primarily how I will present how the industry itself is transforming right now, considering the demands or expectations of the people who wants to kind of take up this. So very briefly, I represent KPIT, who primarily focuses on automotive engineering, and we are about 12,000 plus automobiliers who actually develop the software that goes inside the car, and not just IT systems. Primarily, that's what we drive the car. And so today, I will start with introducing you to software-defined vehicles, what we call. This is a new paradigm that has come in the industry, which means that most of the softwares, the transformation that is happening in automotive industry is bringing a new paradigms to be adopted in this space. So if you see most of the demands that you may have also experienced, that I showed on the right, on the left, on that corner, which is most of the cars are now connected, are having some of the autonomous features. Also, shared mobility is something that we use on everyday basis, and also electrification of the car. So these are the recent paradigm shifts that we have seen in the automotive space here. But software-defined vehicle, when most of the car manufacturers looked at these new paradigms, they looked at we cannot build these features inside the car that is currently running without doing a transformational shift in the way we are developing the car. And most of the people are now used to looking at new models of a phone that is coming on regular basis. Say every year there's a new model that comes. That doesn't happen with a car. You buy a car, you stay with it for 3 years, 5 years, 10 years, and you still want to adopt those features that come. So when we are expecting that we are going to draw the parallels with the phones that we are using, or for the other aspects that exist, we are primarily putting a lot of expectations on car manufacturers to actually bring these features. So they are looking at some of the paradigm shift. So not only in mechanical inventions that used to happen in automotive primarily, but also the new age cars are now full blown software platforms. So like any banking system or like any other system that we deploy, most of the technologies are now coming to the car. You will be able to see that most of these aspects are also available in the car. And the role of AI in this case is also very predominant, because unless we bring the AI into the equation of building the car, it is not going to actually give us all those features that we want. So, for example, the advanced driver assist that was spoken, so or autonomous driving, that as a feature, or preventive maintenance. We heard about preventive maintenance in manufacturing some in the previous session, but preventive maintenance of the cars that are running on the road, making sure that we give alerts when, say, a brake pedal is loose, or when we there's oil change that is required. So all that is primarily are important. And the software defined vehicle, so essentially continuously updating software is going to be the key in such cases, and that's where we will see a lot of things that will come in the future cars. And to adopt that, industry has taken a fresh look. Most of the car manufacturers are now moving to software-defined vehicle platforms. So basically, a central compute architecture, which means there is a single computer that is running all the systems with a high-end, and all systems are linked to each other, versus different ECUs that used to be there in the car, one for just taking the window up, one for running your engine, one for infotainment. So no more. Now we will have a central compute that will actually drive all that. And if you see the complexity, a car generally now goes up to 100 million lines of code, because everything that runs, the features are now are given through the software. So mostly, so as I said, cars are now becoming full-blown software platforms. So it has all the necessary things that are required to do this. And this fresh look that the car manufacturers needed to give for doing this have brought in a lot of transformational change. And AI is a cornerstone in such cases. So I will talk very briefly about the use cases that exist from an AI point of view in an automotive engineering space primarily. First is autonomous driving. We heard that the Tesla is running on its own. That's or the features that are primarily so. Adaptive cruise control is another feature which allows people to do this. The lane change detections. We have level 0 to level 6 type of autonomous driving that exists. So all that is primarily uses a lot of AI models that learns from each other. So there is a model that is created, and fundamentally we take the look at process the data from various sensors that are attached to a car, and actually build the patterns of how the car should take the next decision when the decision comes. So that is something that is primarily built using the AI models. And interesting is, most of the car manufacturers, I have worked personally on these projects with at least 3 or 4 car manufacturers, leading car manufacturers, and they primarily drive this through a continuous integration, that basically making sure that a particular scenario was missed by an AI algorithm, then the model is enhanced on an ongoing basis and deployed into the cars using CI/CD. That's the real application of CI/CD that we have seen, where the autonomous driving models are actually given back to the on very regular basis. So that is one of the application of the AI that has come in, primarily which takes the decisions in whatever it comes in front of the car as such. Second, specifically on predictive maintenance, it's obvious. I mean, as such, primary objective is to reduce downtime of a car, making sure the car is continuously running and gives good experience to the end user who is using it, either as a passenger or as a driver. So monitoring driver behavior, making sure the driver is using the car correctly, all that is primarily learned through the data that is received on this, and this behavior patterns actually tells on how to improve the car, as well as giving feedback to the driver on these aspects. Also, performance of the fleets, for example, we saw that shared mobility is something that is gaining momentum in most of the countries right now. And so fleet management and managing the performance of a fleet and making sure they are optimally deployed is also something that an AI application or AI model can use. So this is primarily one of the other aspects. And personalized user experience is one of the biggest beneficiary of deploying artificial intelligence in the car. Primarily have so, for example, in cases of when I'm driving my car and when my wife drives the same car, it understands who is driving the car and basically personalize it according to the driver who is. So then the car knows which songs to play when I'm driving and which songs to play when my wife is driving. So this kind of personalization is possible because of learning from how I drive the car versus how my wife drives the car at the same time. So this is another piece of AI integration that has actually helped. It also helped in doing some of the other aspects, for example, route optimizations. So the way the map shows me the route from point A to point B versus it shows to my wife from point A to point B may be different, because she may not like to go in closed roads or narrow lanes and want to take in highways or something. So according to the preferences, it can also adopt the road conditions and this. And this aspect can be personalized and learned over a period of time. So this actually gives a lot of applications to be built in using AI and AI ML technologies that exist in the industry. And actually, as I said, cars are now software platforms. So any good application of using this kind of data and building your own applications using AI or otherwise is available, and that field has been democratized. So like like introducing the iPhone or the phones and creating app stores created the whole new industry of app development. Here, using the car data and this kind of information is now creating a new industry completely in terms of how and what needs to be done. So there are ample opportunities to actually deploy the models that are already developed in some other use case context, also in case of automotive as well, or for the car running the car itself. So that is something that we will see more and more new age companies that will come and actually gain prominence in automotive segment, on the not only just BMWs or Mercedes, but we will now also see some of the new age companies in that space primarily. And last year, last 1.5 year, we have seen peak hype of generative AI coming in, and it's a wonderful technology. Everyone have seen what it can do, and predominantly generative AI specifically means that the content can be generated in case of this. So there are obvious use cases in the industry that we had seen earlier. There was a presentation about where these can be adopted easily, say marketing or legal, and these industries are definitely strong beneficiaries of generative AI, but it is also reshaping the automotive design and development as such. I'll give you some examples and how automotive industry is embracing generative AI specifically. Now, when there was a new car model to be designed, and or a new part inside a car to be designed, it used to take a lot of efforts. For example, the artist used to sketch the model that needs to be done, and then somebody needs to then convert it into a 2D model and then to a 3D model, and then it is given to a engineering team to actually work on it. So now when someone actually draws a sketch of a car or a car part, the generative AI can actually generate the 3D model directly, and that way the whole process of trying out different things on how it will actually look on the ground is shortened by miles actually. So because there is no intermediate steps that are required now, if you have a sketch, then you can actually generate a 2D or a 3D model immediately, and can actually benchmark that for the various things. So you can do the A/B testing, you can do these aspects quite easily and quickly. So that's very important. So the innovative design and manufacturing talks about that primarily. We are able to sketch the 3D drawings, or the good practices of styling has come in. So what it means that if I have one person in my company who actually understands the best way to draw everything, or use the best practices around it, then the same thing can be done for X number of things. So I don't need to put in a lot of efforts to do that. Another good advantage is all the best practices around the model designs are now applied here. So that means if I have a sustainability goal, if I have to use the materials that are more sustainable, more friendly, then that can be given as an input, and that can actually automatically will come in. I don't need to teach my engineer, or the person who is sketching doesn't need to know about all these aspects. So that is one of the important aspect of generative AI is bringing in. So next is simulation and safety testing. So simulation primarily means, like we said, that there are new scenarios that are coming in, and we need to test this. So when a car is going to run autonomous, or when the car is going to run driverless, that means we will also need that to test different scenarios that may exist, and it is not always possible to test them on the road when the actual traffic is flowing. So all that needs to be simulated in on the computer itself, and this aspect is very important. So now it was not possible earlier to do all this testing very easily. Now with the generative AI, we can generate different scenarios that exist on the road. So the packages like Stable Diffusion along with ChatGPT can actually generate different types of scenarios and give us for testing those scenarios. So we can say that I want a particular, say, a rainy day in Pune, Shaniwar Pet, and then it can generate that kind of scenario, and I can drive my car in a test mode there. So, so environment traffic simulations is possible through that. Next is customizations. Now, personal desires now can be converted into the personalization specs. Say now, Porsche has actually developed this application. You just need to tell the application that I want a such and such car. So you can specify that I want the Bose audio system, I want this in my car, I want that my car, just plain in your plain English. And it can actually generate the specification for the car, which can be then ordered and get it delivered to you. So Porsche has already is able to close to 90% they are able to actually match the customer specification. So as I said earlier, the mass customization is going to be there. Everyone can customize their cars that come in the this, but it is possible now to just specify those specification in plain English and actually do this. So that's going to be important. Also, conversational AI is going to be very important feature in terms of generative AI point of view. That, for example, the Hello Mercedes, which or most of the cars now have a voice assistant, which can actually take the commands from you and actually work on those commands in the context of the driving that is happening. So that is something that we will that is possible to do. And lastly, it is not only helped to develop the car for the car that is running, but also to develop those features. So running, it can, since the generative AI can generate the code and test cases for it, we are able to see that the code that is more safer, more compliant to quality, which is required for an automotive grade code, can be now generated through this mechanism. So we don't rely on manual coding efforts, which can have these lacunas. So that is something that we have seen in this aspect. So generative AI is going to bring in a lot of these aspects into this. So in conclusion, AI's role in automotive primarily is very foundational now in the new context and very expansive. And it is redefining the relationship with the overall technology that is happening. And for smart, safe, and the case that I talked about, it is very important that most of these features will come through an AI, and we will see more safer, more smarter cars on the road because of this smart technologies that we are going to put in the car. Thanks for your time.
And thank you, Samir. That was very insightful. I have a quick question for you, though.
Sure.
So you mentioned about the autonomous level 0 to 6 in the car. Now, is it something that the car decides, or based on the driver behavior, or is it something you set?
No. No, they are labels that our car manufacturer puts in the car. So, for example,
No, but is it something that you select, like a switch?
no. They are part of the specification. So, it's like going from fully manual car to hands-off completely.
Okay.
So there is no driver. So no driver is level 6 versus level 0 is there's no AI in that.
Can you step this side, please? I'll get you the menu.
Yeah, sure.
Get the NASCAR logo.